Good. Welcome back to my channel. We're going into part three of Steve Fambro, the CEO of Aptera, or one of them. And he is actually on a climate change with Matt Mattern. And he's talking about the future of Aptera. In this part right here, he's actually talking about how um, he developed Aptera and how he went about making it happen, and also talking about how the CPC was actually the best fit for them because they could mass produce since they were already in that business. So let's go ahead and get into it.
Climate change, and I've got Steve Fambro, CEO of Aptera, exciting new car company. And Steve, you talked about the 40,000 pre-orders that you have for the vehicle. I have to disclose that I am one of those pre-orders. So
they told me.
Yeah, I really liked both the design of the car, and I love the fact that it can charge, can kind of go off grid, as well as the 1,000-mile charge. All those things are amazing, and it's kind of challenging the status quo in so many different levels. It's a fantastic kind of revolutionary vehicle. Tell us a little bit more about the design and how you came up with it. You were telling us a bit before the break, and I'd like to hear more about that.
So when the light went on in my head, I mean, I was an electrical engineer at the time. I worked for a biotech company here in San Diego, Illumina. And when the light went on, that if we could make the drag somehow go to zero or lower it by an order of magnitude, then we could have, we could increase the range by a factor of 10 of an electric vehicle on the highway. And so that, I'm also a pilot, and I was looking at different airplanes to build. So I'm somewhat aware of aerodynamics. So I bought all the books that I could buy on aerodynamics and aerodynamics for vehicles, ground vehicles. And I started looking at the books for the solar racers, the ones that, or the Eco Marathon, the Shell Eco Marathon, where they go like 1,000 miles, 2,000 miles on a gallon of gas. These little aerodynamic coffin-looking things where people lay down in them and they go around a track. So I started looking in that direction, and I realized that the vehicle aerodynamics for something in the air, and what they call the free stream, is very different than when you approach the ground. That's in ground effect. The air behaves differently, and the vehicle has to be designed differently to take advantage of that. And that's really the genesis of how we got started. We started with a cambered body, which originally was developed by Dr. Morelli in Italy. And we took that cambered body and started working with our designers and said, how do we make this into a road vehicle? How do we fit two people side by side in it? How do we change it to make it more stylish but not increase the drag? So we started using computational fluid dynamics, and we needed to validate the design. We needed a stamp, something that when we were talking to investors that they would believe us. And so we hired NASA Langley to simulate our vehicle in their low-speed wind tunnel in their CFD processing center. Back then, CFD was a really big deal, required lots and lots of computers. Now it can be done on a desktop or Amazon servers. It was the first check we wrote starting the company. It was like $15,000 to NASA to do this study back in 2006. And they said there's some problems, and they wanted to get us on a call. And so Chris and I were on a conference call with like 10 NASA engineers, and they said, what wizardry are you guys using? How is this possible? There's no way the drag of this vehicle can really be 0.12 or whatever it was at the time. And we said, well, you're NASA, you're the experts, you tell us, that's why we hired you. And it was one of those aha moments where we said, these guys are very smart. I don't mean that in a negative way. I mean, they're NASA, right? They can put people on the moon. But we realized that as a company, this was something we couldn't outsource. We had to own it. We had to have aerodynamicists in-house. We had to build a cluster, Linux servers to run the CFD software, because because NASA was so perplexed. We said, we just have to know everything about this. We have to own this segment.
I'm going to pause it right there, because that was very smart on their part to go to the engineers of NASA to solidify what they had actually produced was really aerodynamic, and that just confirmed what they was creating. So that was really smart on their part to do that. And they had not one engineer, but several engineers that actually was perplexed by what they came out with. So yeah, very, very good. All right, let's go on to what else he's going to talk about.
We did the same thing with solar, basically creating this entire department for solar electronics and everything else. But that efficiency, the lightweight, the composites, and also the low drag, it means that our vehicle uses, a third, maybe a fourth of the power per distance of a typical electric vehicle. And that's better for everybody, because that's fewer batteries, that's less cost, it's fewer mining resources that have to be used. It means it's more affordable. So this relentless, almost like dogmatic pursuit of efficiency within our company really enables the vehicle to go a long way with very little batteries, with a fraction of batteries that any competitive product has.
Well, I think that's a real revolutionary kind of concept, which is to have vehicles that are, more commuter vehicles. I mean, this is a commuter vehicle. It's not hauling a lot of stuff, but I mean, probably 90% or 95% of our trips as drivers are spent in solo trips, or maybe with two people. We're not hauling a lot of bags or anything like that. That's why this technology is so useful for us. We're wasting a lot of energy by driving big cars that are not aerodynamic, correct?
Oh, absolutely. The EV truck wars, I don't think, is where the environment needs to go. We don't need mining batteries has a cost. There's an environmental cost with everything that humans do. So we have to be mindful of it. And steering the technology to use fewer and fewer resources is really how engineering has been done, electrical engineering especially. Transistors get more efficient, they get smaller. That's the natural progress of things. So to see, 10,000 pound vehicles full of batteries just so they look like a regular truck or SUV that people are used to, I don't think this is the way. I don't think this is sustainable. It's going to require extraordinary amounts of power to be brought to different charging locations. It's going to take a long time to charge. It's going to use a lot of batteries. It feels like the wrong direction to us. And so that's why we're going in the opposite direction, or a direction that uses fewer resources. It uses them wisely. It stretches them out over a really long distance and gives the customer, I think, a really good value.
So in terms of the CPC, the company that is making these new carbon fiber parts for you, where do you see this going? I mean, is this new process that they have, is that something that any other company on the planet can do, or is it kind of a patented technology? And where do you kind of see this going, in the future? And why did they pick you to work with when their normal customers are Lamborghini and Ferrari?
CPC has been growing their business. It's one of these quiet companies that people haven't heard about. And I joke every time we go back there's a new building, there's a new campus, something is new and bigger and better about them. They just completed a 12-story tower, which is now the new office. They do supercars well, and it's made them a lot of money. And it's a great segment that has grown them to where they are. But they are looking at companies like Aptera or Tesla and seeing this growth in electric vehicles, and they're saying, wait a minute, electric vehicles really have to be mindful of weight, because they're all trying to lightweight. They're making structures out of aluminum. They're starting to use composites, and they're saying we've been doing that all along. So we want to go after this new industry, and our technology. I'm using CPC's voice. CPC's technology gives them the ability to scale at really high volumes, unlike composites has been able to do so in the past. And so the relationship between Aptera and CPC lets them really demonstrate that at scale. They can talk about it all day long, but if they can produce an affordable electric vehicle that's extremely lightweight, that is indicative of the process or representative of the process that they would use to do other vehicles for other companies, that's what they're also trying to achieve. They're going to have a lot of business with Aptera, and they're going to make a lot of money with Aptera. But they're also looking, beyond who are the other companies that they can continue to grow their business with even higher volumes. Aptera, even at 40,000 units a year, is still low volume compared to Detroit standards. There's lots of vendors in Detroit that wouldn't even take meetings with us because our volumes are just too low. They don't do anything below 100,000 a year. So that's another reason why we ended up going to Italy, is there is this ecosystem of suppliers whose volumes are right around our sweet spot. Their sweet spot is right around our volumes, I should say. But CPC is instrumental in that, because there's nobody else in the world that can do high volume automotive composites the way they do. These parts have fasteners that are built in them. They come out ready to be covered with a vinyl wrap. They don't have to be treated or sanded or polished or anything. They are really, I would say, their tribal knowledge and their trade secrets and whatever other IP they have let them make these automotive parts in a way that nobody else in the world, from my knowledge and my research, can do.
Well, it's pretty fascinating. Certainly the Italians are masters at design and have built some of the best cars in the history of car making. So great partners to have on any project. You're listening to A Climate Change. This is Matt Mattern, and I've got Steve Fambro, CEO of Aptera, on the program, and we'll be back in just 1 minute.
Okay, so we're going to stop right there. But yeah, he brings out a lot of good points. Right now, a lot of people, once they see Aptera's efficiency, that it's not only the people that are going to really benefit from that, but the planet Earth all the way around. I mean, you'd be building less batteries because of the efficiency of the vehicle. It needs fewer batteries than a lot of these other EVs that are coming out that needs a ton of batteries. And so we need to try to stay away from that. And as far as mining goes, that'll be less. It'll be easier on the grid and just all the way around. I mean, better for the air. I mean, the Earth is really getting in a very dangerous place right now with all the hurricanes and fires that are happening. But yes, I'm gonna end it right there, and just want you to stay tuned for part 3. That'll most likely be coming out tomorrow. I'm sorry, not part 3, part 4. That'll most likely be coming out tomorrow. So I'm gonna give a shout out to my patrons. You guys, y'all just the coolest people in the world. I really appreciate you, and thank you for watching my channel. We got one more that's going to come out, part 4, and make sure you check this out. This is going to be really good. And if you're new here, go ahead and hit the subscribe, smash the like, ring the bell, and you get to check all my videos when they come out. You'll be notified of it. All right, you guys have a good one. We will talk to you later. Bye-bye.